the electron transport chain. Uh, what's going to happen here is that these electron carriers are actually going to drop off, okay, hydrogens in these enzymes embedded within the membrane. Okay? Now remember, electron transport chain is a membrane dependent reaction, so this is the cell membrane within bacteria. Okay? It's not happening in the mitochondria. Okay? It's a cell membrane within bacteria. And what's going to happen is these molecules are actually going to begin to pump hydrogens, okay, across the outer surface. Okay? Pumping those hydrogens across creates a concentration gradient. We have lots of hydrogens here, okay, on the outside, and fewer hydrogens on this side. Okay? The electrons that are associated with the hydrogens are actually going to get pulled off, okay, and move through these molecules, and they're going to provide some of the energy to pump those hydrogens across. Okay? This is what we call a proton pump because the electrons are gone, the hydrogens end up positively charged, so they're protons. Okay? These proton pumps pump the hydrogens across, and we have a concentration gradient. Lots of hydrogens over here. Well, the hydrogens want to come back through, okay, because they want to even everything out. The only way to get back through is to come through a large enzyme called ATP synthase. Okay? ATP synthase will allow the hydrogens back through, and it will actually let them pair back up with their electrons. But when the hydrogens come back through, the energy that they have is actually going to be used to fuel the reaction of this ATP synthase, and the ATP synthase is going to add free phosphates to ADP to make ATP. So those hydrogens that get dropped off from the NADHs, okay, are actually going to be converted into ATP. Remember I said